Okay, so in my last video of this series, we're going to be looking at what I kind of consider some step-up problems. I call them this simply because the way that some of our answers are going to look are going to be a little bit quote-unquote uglier than what we've seen before, and that's because we're going to notice that some of the sites we've been given don't follow the pattern we're used to. Now, our relationship of what we've noticed before for a 30, 60, 90, and for a 45, 45, 90 are still going to exist, and we're still going to use them, but the numbers in solving might just look a little bit more complex. So let's start with this first one. I noticed that I was given my hypotenuse, which is 3. And I know that my hypotenuse is always double my short leg. Once again, I know the one I just highlighted is my short leg because it is directly across from my 30-degree angle. Now, if this is double this, that means that really what I need to do to go from the hypotenuse to the short leg is to half it. Well, when I half 3, that doesn't simplify any further. There is no half of 3. It's not an even number, so I can't divide it by 2. So my short leg simply is 3 halves. Another way that I could have done that for those of you guys who are a little bit more algebraic minded is I know that if I call this side x, then this should be 2x. So 3 should be equal to 2x, and I can divide both sides by 2 to get x is equal to 3 halves. So that is kind of what we did to get from the hypotenuse to the short leg. And that's why I said it might look a little bit uglier because now we have a fraction, but that's okay. It's still mathematically true. Now we know that once we have the short leg, we can find our long leg. In order to find the long leg, we take what we have on the short leg and simply multiply it by the square root of 3. So I'm going to take my 3 halves and multiply it by the square root of 3. And when we multiply, that goes into the numerator. And so I get 3 root 3 over 2. Now, oftentimes you'll see the 2 written in the center. That is purely aesthetic on how you want to see that. So it's still the same pattern. Our numbers just look a little bit more complex. Let's do one more example. So in this case, I notice that I'm going across from my 60 degree to get the 10. Now this one is actually my long leg. And normally my long leg, even here, notice my long leg had a square root of 3 in it. But this time it doesn't. So that means I'm going to have to see that square root of 3 relationship somewhere else. Once again, I think the easiest thing to do here is to label your short leg x. And if your short leg is x, then this side is always x times root 3. So in order to figure out what my x is, I'm going to divide both sides by root 3. So my short side should be equal to 10 times the square root of 3. There's only one small problem with this answer, though. We don't expect or we don't like to keep a radical in the denominator. You can't really divide by a number that never ends. So we want to do what is known as rationalizing. So 10 over the square root of 3. Because this is a square root, you get rid of a square root by squaring it. So squaring it just means multiplying it by itself. However, I can't change the value by multiplying by something. The only number I'm allowed to multiply by is 1. So to make this whole fraction equal to 1, I need to multiply by the square root of 3 on top. That means that my final answer here for the short leg is actually 10 root 3 over, now the square root of 3 times the square root of 3. The whole purpose is getting rid of the square root, so it is simply 3. So a little bit harder here. We had to set up that ratio I just erased over here to figure out what our short leg was. And then once we had it, we had to go ahead and what's known as rationalize it. We had to get the radical out of the denominator. Lastly, once we have our short leg, we can actually just go ahead and find our hypotenuse. We're still just simply going to double what we already have. We're going to double the short leg. So I'm going to take 10 times root 3 over 3 and multiply it by 2. Well, that just ends up being 10 times 2 in the numerator to give me 20 root 3 over 3. Once again, the relationship still exists. If I were to take this and double it, I get my hypotenuse. If I were to take my short leg and multiply it by the square root of 3, and you can really see that down here. If I were to take my short leg when it's in its unrationalized form and multiply it by the square root of 3, that square root of 3 would cancel, leaving me with 10. So our relationship still exists. It just looks a little bit more complex. Let's now go to the 45, 45, 90s. We're going to see something similar here with having to deal with the square root in a way that looks a little bit different. We know that normally we could label in a 45, 45, 90 our two sides as x because they're going to be exactly the same. Well, if they're x, then our hypotenuse is typically x times the square root of 2. But I don't currently have a square root here. So because I don't have a square root in the one that normally does, I'm going to need to see that over here somewhere. I can do like I did before, and I can set my hypotenuse value of 7 equal to the ratio we expect, x times the square root of 2. Well, to get x by itself, we're going to divide by the square root of 2, which tells me that my side length should be 7 over root 2. However, we still have that problem where we don't like having the square root in the denominator. So once again, to get rid of it, I'm going to multiply it by itself. But because I can only multiply by the value of 1, I need to multiply by that on top and bottom. Once again, this is what we call a well-chosen 1. It's well chosen because it's helping me in the problem. It's 1 because it actually reduces down to 1. So when I multiply, it doesn't change the value of my whole side length. Therefore, the final answer for the side length here would be 7 square root of 2 over 2. If that's this side, that is also this side, because that's the big quality of the 45, 45, 90. All right, let's do one more. I have another 45, 45, 90, but when I look at it, I'm actually given one of my side lengths, and my side length has this interesting square root in it. I know in a 45, 45, 90, my two sides are going to be the same, so I can go ahead and put that here. But then in order to get to my hypotenuse, I need to multiply that by the square root of 2. Now I'm going to show you two different ways to do this. I'm going to show you the way that most people would start, which is simply taking what we have and multiplying it by the square root of 2. If I multiply it by the square root of 2, notice I have square root of 2 times square root of 2. When we square a square root, it undoes itself, so that just ends up being 2. So I end up with 3 times 2 over 2. The 2's cancel, leaving me simply with 3. So here, I took my leg, I multiplied by the square root of 2. These, because you squared a square root, we're just left with the inside, and then the 2 on the top canceled with the 2 on the bottom to give me just 3. There's another way I could have done this, though, and it would have taken a little bit of prior knowledge, but over here, I noticed that 7 root 2 became 7 root 2 over 2. So once again, sorry, I think I said that incorrectly. 7 divided by the square root of 2 is equivalent to 7 times root 2 over 2. Therefore, I could actually say that 3 square root of 2 over 2 is equal to 3 over the square root of 2. So really just unrationalizing this. So by unrationalizing my leg, I can still find my hypotenuse by quickly multiplying it by the square root of 2. And in this case, the square root of 2's cancel, leaving me with just 3 again. So this was one method. This was another method. They got me to the same answer of 3. Zoom out before I end. I do want to make the note that if you don't have a square root in the side length that you expect to see that square root. So normally we expect to see the square root across from the 60. Normally we expect to see the square root and the hypotenuse of a 45, 45, 90. If you don't see the square root there, that simply means you're going to see that square root relationship in the other side lengths. So by not having it here, I actually had a square root of 3 in my short leg in my hypotenuse. By not having a square root in my hypotenuse, I have a square root in my two legs. Because I have a square root in my two legs, I did not have one in the hypotenuse. So that's just something that can help us out as we solve. And there you have it. Throughout all of these videos, we've looked at the many different ways that we can use the ratios of the special right triangle to find the missing side lengths.